just going to show you what to do. Okay, it's the last one that has a set formula. So what we're going to do is take the value of what we're looking for. So this is your x's and this is your y. So if I'm having a fraction, what goes on the top when I'm doing rate of change or slope? Sorry? Our y values, right? So we're going to do our y values. Okay, but before we get to the y values, we're looking at this point here. Okay, so we're doing f at 0.5. So yesterday when I did that, we were plugging it, so f at 0.5, which will give you your y value. Okay, so we're looking at, sorry, I should put t. No, it's going to be h at 0.5. No, t at 5, h. Okay, so this is going to say, what is our height when our time is a half? So preceding, what does preceding mean? If you had to give it a word to it, preceding. Preceding.
Emma knows.
Huh?
Emma knows.
Emma knows?
Yeah, I have no idea.
Preceding? Just threw her under the bus, eh? By the way,
No.
her birthday's in April.
What's the day? Yeah.
I forgot.
Uh,
That's close to mine.
you have it right there. Are we interrupting the lesson for this?
That's okay. Number 9. Okay, preceding is what?
Isn't that like
Before. Good.
Don't
Wow,
copy
that
me.
was a-
I said that.
Okay, so preceding is before. So we're going to take the point that we're looking at, which is 0.5, and then we're going to take the point before it. Okay? It's up to you which point you want to use. So you can use the 0.25 or you can use the 0. Okay, I'm just going to do the one that's next to it, so I'm going to use this point here. So we want to know, we're going to subtract, because when we're doing slope or rate of change, where we subtract. So we're going to subtract the height at 0.25. And at the bottom, it's your x values, which is 0.5 minus 0.25. I know I could have just put the y values in right away, but sometimes they're not given to you. So we're going to take the point that we're looking at, which is 0.5, and then take a point before it. That's why it's saying preceding, so we're taking the point before it. Okay, so what is the height at 0.5 seconds? What's the height?
7.4.
It's what?
7.4.
7.4. So 7.4, subtract the height at 0.25, which is 5.5, divided by 0.5 minus 0.25. Okay, now we solve it. So that's 1.9 divided by 0.25. It's 7.6 meters per second. Okay, so preceding is we take the point we're looking at, which in this case is 0.5, take the point before it, okay? When it says before, you can choose which point you want to use, whether it's 0.25 or 0. Okay, sometimes 0 might be easier to use, okay? But I'll tell you what happens if you do choose the different point, then your following one, you have to choose a different point. Okay, so we did preceding. So this, what it's telling you is what is the rate of change right before half a second? So right now we're finding out the rate of change before 0.5. Now we're going to find the rate of change after 0.5. Okay, so preceding is before, following is after. So we're gonna take the higher point. What point are we gonna use afterwards? We're gonna use 0.75. So h at 0.75, subtract h at 0.5, all over 0.75 minus 0.5. I always put the larger number first. Okay, so our half was larger, so I put that first. And now the 0.75 is larger, so I put that first. Okay, so what's the height at 0.75? The height is, Brooke? 8.1. Subtract the height at a half, which we already know is 7.4. All over 0.75, subtract 0.5. Which is 0.7 over 0.25. Which gives us 2.8 meters per second. And how do I know my units? Well, it's here, meters per second. Okay, so preceding and following, we take the rate right before the point we're looking at, then we take the rate right after it. Okay? But the question's asking, what is the rate of change at that point? So we did before, we did after. I want to take a guess what we do next. So what we're going to do is average it out now. Okay? So we did the rate just before, the rate just after. If we average it out, it'll give us the point, the rate at that point. Okay? So now we're going to do the average. So how do we do average? Add them together and divide by 2. So 7.6 plus 2.8 divided by 2. So 10.4 divided by 2 is 5.2 meters per second. So preceding and following and the difference quotient method have 3 steps. It's always the before, the after, and then the average. Okay, so one thing to keep an eye on, everyone needs to pay attention here. So I told you that you could use either one of these points before, okay? If I were to have used this point, can I still use the 0.75? Alex? No. Okay, any reason why?
It would probably have to be kind of
The same distance, good. Exactly. So if I go half a second before, then I have to go a half a second later. So if I choose this point to use, I have to use that point. So your interval has to be the same. The interval has to be the same. So if I use a quarter before, then I can use a quarter after. If I use half a second before, then I have to use a half a second after. That's a must. Okay, you can't use this one and then use, I don't know, 1.5. Okay, because your interval is a half a second here, whereas that one would be a full second. So you can't do that. So make sure your interval is the same on both sides. Okay? Sometimes you won't get a chart, so then you make the interval. Okay, so if it says what is the instantaneous rate at 5, then you could do like 4 and 6. Okay, so you can make them. Okay, now I'm going to show you the second method here. Okay, so the second method is centered interval strategy. This one's the easiest one to do. It only takes one step. That's why most students like this one. Preceding and following takes 3 steps. Preceding, the following, and then the average. Okay, centered is just 1 step. So what centered is, you take a point before and a point after, and then you do those 2. Okay? So for centered, we're not going to use this point here. Even though we're looking at 0.5, we're not going to use 0.5. What we do instead is we take a point before and then a point after. So we're going to do, and the interval still has to be the same. So if you use a quarter before, you have to do a quarter after. Okay, same thing with the intervals. So what we have is, we want the height at 0.75, subtract the height at 0.25, all over 0.75 minus 0.25. Okay, so centered, take the point, take the after, before and after. Okay, but don't use the actual point itself. So, okay, since we're looking at 0.5, exactly 0.5, so we'll take a before and after. So 0.75 and 0.25. So we plug that in, so we get 8.1, subtract 5.5, all over 0.75 minus 0.25. Gives us 2.6 divided by 0.25 for 8, 10 points.
0.5.
Oh, sorry, that's why. My fault. Thank you. So 5.2. Which ends up being the same as the one we just did. Okay? It's not always going to work out exactly the same. Each one will give you a different answer. Okay, this one's the least accurate one. Okay, but the quickest. Any questions so far? Preceding and following, the preceding, so that point plus a little piece before it. Following is that point plus the one after it, then we average them out. Centered, we don't actually use the point we're looking at, which is 0.5. We're not going to use this point, yet we use a point after, or before and after. Good. Anyone not have it yet? Last question. There's a C down here. Okay, a town's population is modeled by the equation. Okay, what type of function is this? Type of function? Quadratic, good, because we have a squared. Our PT is the town's population, and T is the number of years since 1994. Okay, so some simple questions first. What is the town's population in the year 2005? What is the town's population? So we're looking for PT, we're looking for the population in the year 2005. So how would I find this one? Using our equation, how could I find the population? Haley?
Calculate the amount of years from 1994 to 2005 and then use that as T.
Perfect. So we're gonna find it. So T is the number of years since 1994. Okay, so we're gonna substitute a value into T, and once we find substitute T, we'll find a population. So what do I plug into T? Well, how many years has it been since 1994 to 2005? It's been 11. Okay, so we're gonna do P at 11 because it's 11 years. So 15 at 11 squared plus 20,000. So I get, you guys can double check it for me, 21,815. Okay, so A, what's the population? Well, the population is 21,815. Okay, B, determine the average rate of change from 2005 to 2000. Okay, so keyword, average. So average, and they give us 2 points to use. so this would be f at x2 minus f at x1 all over x2 minus x1. Alright, so yesterday's lesson was this. So f, yesterday's lesson, f at x2 minus f at x1, just means y2 but y1, same thing, over x2 minus x1. Okay, but we did, remember we changed the y's into f at x's now, right? So we're doing that right here, so this will be p. Okay, so we're doing, instead of f, it's p now because we're doing population. So the population at x2 minus the population at x1, all over x2 minus x1. So it tells us we're going from 2000 to 2005. So from 2000 to 2005. So my x2 is 2005, my x1 is 2000. But I can't use them the way they are. I can't use them as they are. What do I use instead of 2005?
11.
Sorry?
11.
11. So 11's, remember, it's 11 years since. So we're going to do 11, subtract, so it'll be p at 11, subtract p at 2000. Okay, but we're not going to use the 2000. How many years has it been since 1994? 6. So 11 minus 6. Okay, but we don't have a chart this time. Last time we had a chart, so we could look, well, what's the value for it? We just pulled it from the chart. Okay, now we don't have one. How do I find p at 11? We already did it, right? We just did p at 11, we did it over here, right? P at 11 is 21,815. So p at 11 is 21,815. How do I find p at 6? How do I find the value for p at 6? Really?
Replace t with 6 in the equation.
Good, so we put 6 into the equation and then solve to get the answer. Okay, so we're actually going to calculate it. So p at 6, I'll just do it on the side here. So p at 6 is 15 times 6 squared plus 20,000. 36, 15, 30, 18, 06. You get 540. So 20,540. Is that right?
Yeah.
So then if you substitute it in, you get 20,540. So 20,540. And now we subtract, because we're doing average rate change, and divide. So we get 275 to, nope, 1,000. 275 divided by 5 equals 2, 5, 5. Is that right? Okay. 255 what? Rate change has units. What are my units here? What would be my units? Who said it? Alex, are you? I can't see your votes going.
Population per year.
Okay, don't say population. What would it be then?
PT over T.
Sorry? Well, population is what?
People.
People, yeah, people per year. Okay, so let's go growing by 255 people per year. Questions? We get to the last one. Good? Okay, now we're gonna do the last one, which is difference quotient. Okay, so this is the last one, which is called the difference quotient. It's the same process as the preceding and following. Okay? The only difference is preceding and following, you could choose the points you want to do before and after. For difference quotient, you have to use 0.01 before and 0.01 after. Okay? So the H is always, always, always going to be 0.01. I think some textbooks or some teachers do 0.001, but for us, 0.01 always. Okay? Again, preceding and following, you could choose the point before and after. Difference quotient, you have to use 0.01 before and 0.01 after. And then, so we're going to do the before, we'll do the after, and then we average it out. So same steps. Okay. So first one, we're looking at year 2005. Again, we're not putting 2005 into the equation. We are putting what number again? We are putting 11. Okay, so this was F at 11 or P at 11. So I'll just write P at 11 because that's what it was in the previous questions. So P at 11. So now it's A minus H. A is your 11. That's the value you're looking at. A is the value you're looking at, in this case it's 2005, which is 11. Okay, 11 years since 1994. Okay, now we're doing A minus H. So it's 11 minus 0.01. What is 11 minus 0.01? 10.99. So 11 minus 0.01. All over H. The denominator is always going to be 0.01. Okay, so let's solve it now. Give you guys a minute to get caught up. Okay, so P at A or F at A is the value you're looking at. In this case, it's 2005, and 2005 is 11 years past 1994. Then F at A minus H is 11 minus 0.01, which gives us 10.99. Okay, P at 11, we already know the answer from previous question. It is 21,815. Subtract now P at 1099. So 15 times 10.99 squared plus 20,000. And I'm just going to shoot that on the calculator. You guys can confirm this. I get 21,811.70. Actually, I'm going to use 4 decimal places. Sorry? Same thing? Keep 4 decimals. The more decimals you keep here, the more accurate your answer is going to be. So now I actually answer it, 21,815 minus 21,811.7015 divided by 0.01. I get 329.85. People per year. Okay, now we have, sorry, A is still 11. So we have F at A plus H. So 11 plus 0.01 will give us 11.01. I want you guys to try this one out and tell me what you get at the end. I think you should get 330.15. 330.15? Because it should average out to 330 afterwards. Remember, keep your decimals. Should get 330.15. average, add them together, divide by 2. And you get an average of 330 people per year. So once again, preceding and following, you choose the points before and after. Okay, then average it out. The centered method, you don't actually use the point you're looking at. You take one before and after, and it's just one step. And then we have the difference quotient method, which is this one here. So it's the same thing as preceding and following, except for we're taking 0.01 before and 0.01 after. So we're finding the rate just before it, the rate just after, and once we average it out, it tells you the rate at that time. So at 2011 exact time, it's changing by 330 people per year. Okay. Homework is there, page 85, 1, 2, 5, 6, 8, 12A.